Hi there, my name is Abhishek Anand Singh, and I'm working on a research project with international networks. My project is regarding big data and research and education networks. So, I'm working with international networks at Indiana University. International networks at Indiana University is part of a research and education collaboration group that is responsible for delivering network connectivity for scientific collaboration and other research and education networks throughout Europe, Asia, and America, connecting the important research and education institution and users within these countries. And so the two major networks being supported by international networks are America Connects to Europe, or ACE, and Trans-Pacific Connection to Asia, TransPac. America Connects to Europe, as the name suggests, it's a network connection that goes between the research R&D networks between in America and those in Europe. And the same goes for TransPac, which is Trans-Pacific Connection to Asia, which connects American and Asian institutions such as NASA and Japan Aeronautics Research Administration. So the objective of my project is very simple. I want to apply data science to facilitate research within R&D institutions in America, Europe, and Asia with faster and reliable Internet 2.0 connectivity. So, in simple terms, what I want to do is I want to implement my data science tools and techniques to ensure faster and reliable internet connection between these two projects that International Networks is responsible for. That is ACE and Transpac. Now, who will benefit from my efforts? So, the major users of our network are some of the most prominent research administrations in all these three continents. For the major users, for example, are NASA's Jet Propulsion Laboratory in America. They talk a lot with, they talk rather, exchange traffic data over internet traffic, Internet 2.0, with Japan's Aerospace Exploration Agency. So these are like the two most two most important users for us. Other important users are NOAA, the National Oceanic and Atmospheric Administration, and some major universities in Asia, Europe, and America. And these constitutes all of the important, rather major universities in all three continents. The motivation for my project. Now, the international networks, or rather, the international network is an NSF funded project. The projects being carried out by international networks are funded by NSF itself. So they have already set up Internet 2, which is to deliver these these network traffic to these continents, and the infrastructure has already been set up and everything works great. They're providing the best of their capabilities, and but what further we could do was software optimizations and finding patterns and bottlenecks that could be not responsible by those are not really responsible by uh, uh, the infrastructure problems. So for that, we want to with data science, we want to optimize the experience of major users through finding patterns and bottlenecks and uncovering some of the major problems that are going in the network, and find the users who are really important and who share a lot of data over the internet too, and we could serve them better by finding the bottlenecks exactly where they are. And the best part is the data has already been collected over years. It's just been there for so long and nobody used it till now. So it's a perfect place to start with this project. Further, the data are the data is the data we have are the exchanges on these Internet 2.0 networks, which are managed, and the metadata flow is analyzed at the facility in Bloomington of international networks. And this data is gathered from various routers that have been uh, like located in some of the major cities in US, such as Seattle. One of those are in Seattle, Los Angeles, and Ashburn. The next thing is we collect over 2 TB of data a year, so it's a good start for big data. And the data format is roughly the same NetFlow or SFlow format. Networking people are more familiar with these two formats, which contains a lot of fields, but 20 plus fields are what are actually relevant to us for data processing. This is a sample data format, data we have in JSON format. We have things like date start, date end, source and destination IPs. Now we need to anonymize it, but that's the next thing in the process. Currently, we just have it and we are working with it. I mean, due to privacy concerns, we cannot just like make them public yet. And some of the major networking things that we're going to be using for our data science project. Now, the task here is we intend to apply our data science tools to answer two questions, two different portions. Our problem is divided into two different portions. One is give answers to several questions. For some of our major questions are which flows reoccur over time, what is the average flow, what do super big flows look like on these networks, and these big flows are what we really care about, uh, because these users are who are using our networks a lot, and we want to ensure that they get the best service possible, and finding some different patterns and some different patterns over the over the days and weeks and year. If you can see any patterns, that would be useful. And the second part of this problem is creating predictive models which can really predict these super big flows before they actually happen, and ensure that they are getting the resources are efficient and optimized before these super big flows start, so that they can be they can be carried out without any further problems. Our pr- our approach is divided into three phases. First is data pre-processing and storage, which is almost complete, and uh, mm, we are not using any SQL database, of course, since the data is big and sort of structured but still big. So you're using Elasticsearch as a database because it's pretty good with indexing and searching since it's based on Lucene. And the second phase is exploratory data analysis, which is creating the different visualizations and getting intuition about the data. And what is more important here is a real-time monitoring of flows, since the flows will be uh, already always coming in, and we need to monitor them all the time so that we can just like get a dashboard which can show important things. The third phase is to implement machine learning techniques and create the models which will actually predict these significantly large flows. And till the analysis, whatever analysis we have done till now, uh, gave some. I mean, it's mostly the exploratory data analysis till now. We have the data in database, and we're just like getting intuition of the data. So this is just a small example of a sample we had. We just had data over 1 GB and just getting the counts and unique source IPs and destination IPs. So as you can see, in like sample data within a month, it goes to around 57 million records with 318,000 and 582,000 source and destination IPs respectively. So these are pretty impressive numbers. The other thing is we can see how the distribution of protocols are there. So as expected, TCP has the gets the most portion of our entire spectrum, since it's supreme protocol of the data exchange, and it's reliable. So, but there are tons of, but there are different protocols as well, like ICMP, IPv6, and there are others as well. But as we see, TCP is the major one here, the, with more than 56 million records to its name. And then we have, since this is a distribution of input bytes by the IP, so I mean, because of privacy concerns, I cannot show the IPs here. But the first, uh, but the first data point that goes around somewhere between 50 terabytes and 60 terabytes, and is NASA. So that the first one is NASA, which has exchanged data with other organizations up of 50 TBs in 1 month, and just sample data, that's sample data. The second just comes down to around 10 TB, that's NOAA, and so forth. So as you can see, the data is there are lots of data being exchanged over these networks, and it's really important to remove any bottlenecks and improve and optimize these networks. It's a very important project, and I'm really excited to work on this further. So yeah, that's all from my side. Thank you.